Hello and welcome to the subject geology and geotechnical engineering. Today I'm going to deal with the subject lower spheres of the Earth. Regarding the lower spheres of the Earth, there are three and also been separated to subspheres. The Earth's interior spheres starts with the crust, which is the upper part of the Earth, covering the surface of the Earth, and the below materials is the mantle, which is also containing materials under high pressure and temperature, rock materials, dissolved materials, and we have the inner core or the outer core, which is in liquid state and also composing of iron under high temperature and pressure, and the inner core, which is the sphere that centralize the planet Earth. So we have materials in different states. We have the crust, which is in a solid state. We have the mantle, is in a liquid state under high pressure and temperature. We have also the outer core, which is also in liquid state, composing of materials which are different from the material composing the mantle. And we have the solid part of the core, which is composing of iron and nickel alloy. So the crust of the Earth is divided into the continental crust and the oceanic crust. The continental crust is that part of the crust representing our continents of the Earth. The oceanic crust is the part which is composing the oceans floors of the planet Earth. And there are also different thicknesses for these two types of crust. The continental crust can be thick between 50 to 70 kilometers, while the oceanic crust can give us a depth between 25 and 5 kilometers thick at some areas at the oceanic crust. We have also some other places at the continental crust which are not thick enough to prevent the volcanic activities and the materials come up to the surface of the Earth. Examples of for such places or places is the Hawaiian Islands, and also near to the area called the Yellowstone north of the United States. So we have the mantle also. The mantle is also separated or divided into two subspheres. The first one is the upper mantle, and the next one is the second one is the lower mantle. The upper mantle is active. There are many convection currents, and also contains lower high temperature and pressure from the lower mantle, which is usually contains very high temperatures and pressure for the material composing the mantle, which are in liquid state, dissolved, rocked, and flowing under high pressure and temperature. The core of the Earth is also divided into two core or spheres. We have the outer core, composes of iron in liquid phase, and we have the inner core, which is in solid state and composed of iron and nickel alloy. The core is under extreme pressure and temperature, and the pressure and the temperature there is equivalent to the pressure and the temperature at the surface of the sun. So we have around 5.6 million degrees centigrade at the surface of the sun. The core is having such temperature also for the material that it composes of. So we have these cores, and these spheres are separated from each other by boundaries, and these boundaries has been discovered due to the advance in the technology, especially in the seismological technology. We have at the beginning of 60s and to the 70s, 1970s, we have man-made nuclear explosion at the surface of the Earth, and this has been also utilized to also monitor the vibration they made, this type of explosion made through the crust of the Earth and beneath the Earth's surface. So therefore, many stations has been separated at different places at the surface of the Earth, and these stations received the back waves from this explosion. So this explosion sent sound seismic waves below to the Earth component, and this has been received in many places and contains many information about the interior parts or the spheres of the Earth. And therefore we have also very accurate separation boundaries. We call them discontinuities in the seismic waves. We distinguish these discontinuities, and we think that there are also separation boundaries or transferring boundaries between these spheres of the Earth. So we have the boundaries has been also shown here in this diagram, and we have the first boundary is the boundary that separating the crust from the mantle. This boundary calls the Mohorovic boundary, referring to the person who discovered that boundary and suggested that there is a material state change in these boundaries. These boundaries is usually under 5 to 70 kilometers below the Earth's surface, which means that the crust of the Earth is thick between 5 to 70 kilometers. And we have the other boundary, which is separating or separating the two mantle spheres, the lower mantle from the upper mantle. So this boundary is the separating from the mantle core boundary, and we have also boundaries here in this area. So we have the other boundary which is separating the inner core from the outer core, and telling us, give us indications that there is a change in the state of the material from the solid to the liquid, or from the liquid to the solid. The state of pressure, mass, and volume is also shown here, and this information also comes up to us by the seismic waves. The seismic waves are three types. The first type is the shear waves, the S waves. We have the P waves, the primary waves or the pressure waves, and we have the B waves, which is the body waves that can travel horizontally with the crust of the earth and perpendicularly to the direction of the P waves and the S waves. The distribution of these spheres, or the lower spheres, is as the following. We have the crust of the earth occupying 1% of these spheres, and the mantle composing around 46% of these spheres, and the outer core takes around 20% of these spheres, and the inner core is around 33% of the spheres. In many references, the outer core is a part of the mantle. So therefore, the mantle of the earth can be occupying around 66% of the lower spheres of the earth. And this happens, or these assumptions made because the outer core is also in liquid state, just like the mantle. The crust of the earth, and especially the continental crust, the continental crust is flows up on the oceanic basin layer, because it is composed of lighter materials, and the materials that composing the crust or the continental crust is composed from the silica, granitic, and granodiorite rocks. The granitic rocks has a source magma, which is acidic magma, and we have the granodiorite is a composition between the mafic, basic magma, and also the acidic magma, and both have a source from the mantle of the earth, both magmas. The granitic rocks are rich in quartz, feldspar, orthoclase, and plagioclase minerals. And we have the distribution of the spheres of the earth shown in this diagram. We have the core of the earth, or sorry, the crust of the earth is this part of the crust. The crust is the part which our continents are made of. So the continental crust is simply the continents of the earth, the part of the crust. The other type of the crust called the oceanic crust here, and we have just we speak about the Mohorovic discontinuity, which is a separation, seismological separation between the crust and the lower or the upper mantle. So we have the mantle of the earth here. It's also spherical, goes around all over the earth interior sphere, and we have the boundary that distinguished by a person called Repti. We called it the discontinuity, Repti discontinuity, which gives us an indication of changing in materials in the mantle. Therefore, we call it the lower mantle and the upper mantle. The lower mantle here is this space called the lower mantle, which is usually in under high pressure and temperature more than the upper mantle. And we have the person who discovered or suggested the boundary, Gutenberg, and therefore we call it the discontinuity, or this boundary we call it the Gutenberg boundary. And the Gutenberg boundary simply separates the lower mantle from the outer core, and the outer core sphere is this place here, outer core, and the outer core also shown here in this place, and the outer core is also made of materials in liquid state, which are the iron under high pressure and temperature. Lyman discontinuity is the discontinuity that separates the solid inner core from the liquid outer core. The oceanic crust. The oceanic crust is a part of the crust of the Earth and composing a cover, a spherical cover to the surface of the Earth. The oceanic crust shown here in this image, 3D image, it is this part of the crust of the Earth. The oceanic crust also composing the oceanic floor beneath the ocean's water. The trench area between the trench area between the continental and the oceanic crust is shown in this area. The trench area is an active area where the oceanic crust moves below the continental crust, and this movement makes also sometimes some earthquakes without volcanic eruptions, and these earthquakes are huge enough to generate a movement, a huge movement to the water masses above the above the sea level and attacking the shore lines or the coastal lines of the oceans with the continent areas. And these are usually known as tsunamis, which is a result of the earthquakes happens at the oceanic crust. The area here also known as an active area where the materials from the weathering processes usually also accumulate there, and these materials can also show up as mountain change due to the movement between these two continents, and also can also deforms and give us another type of rocks called the metamorphic rocks, or can also go with the part of the oceanic crust to be dissolved here in this area at the subduction zone, and these dissolvations give us materials which are usually having a different density than the materials composing the mantle of the Earth. Due to the differences in the density, these materials can accumulate together and makes the price and rising up to be collide with the lower part of the continental crust, and from the collision process, some earthquakes also happen without volcanic eruptions. The materials here, known as magma, can find its way up to the surface of the earth through the dikes and the siles and the openings in the continental plate to show up as volcanic eruption. And these are volcanic eruptions. There were many millions of volcanic eruptions at the surface of the earth, and these volcanic eruptions brought many materials from the mantle to the surface of the earth to be thick enough to protect the mantle of the earth, and also protect the internal components of the planet Earth. So the materials which come up with the magma as a volcanic eruptions were in two states. The first state is the liquid state, the dissolved rocks and minerals, and the second was in the gas state, composing of gases, and one important gas here was the oxygen, which our atmosphere is composed of. So the oxygen, the most oxygen that come up to the surface of the earth, in fact, come up through the many millions of volcanic eruptions happen to the earth crust, through the earth crust, during the geological time of the earth, which is around 4.6 billions of years. So the discontinuity is representing the transition zone between the solid crust with the liquid materials of the mantle, and transition zones represented also or come up again, or give us information, or take our information from the seismic waves we sent to the below of the earth. The materials in the oceanic crust is consisting of mafic or basaltic rocks rich in pyroxene, olivine, orthoclase, plagioclase, and also feldspar minerals. Usually the basaltic rocks are heavy enough and denser than the continental granitic rocks. In 1912, Alfred Wagner suggested a hypothesis, and this hypothesis proposed that the earth continents have diverged through the geological time relatively to each other, and this divergence also makes a conversion, which means that in some places they crash together, and in other places they went apart from each other. And these continents, of course, has been created from the materials come up through the volcanic eruption to the surface of the earth. The displacement between these continents has been measured to be active, and it is around 2 centimeters per year. According to Wagner, the huge continents was one continent, and he called it the Pangaea, which is a Greek name, of course, and the other part is the super ocean, and he called it the Panthalasia or Panthalasia. So these two things has been there before spreading and break up, and the continent, the huge continent, break up to other small continents. This was the idea of the Alfred Wagner. Nowadays, we believe that the continents has been made separately and been also collide together to make a new continent, a bigger continent, also being separated again to make a small other continents. The following video film, I would like to show you how the idea of the continental drift being proposed. And there the idea, as Wagner has also supposed, it started before 3.3 billion years ago until we see the continents of the earth nowadays. So the following video film is made of this idea of Alfred Wagner. So Alfred Wagner supposed that the continents here, which are showing here in this area, are made of solid rocks and moved against each other or toward each other, and makes new continents, and also separated again to make newer continents. And this makes also that the earth has a geography to the continent and has also a phylogeography to the continents of the earth. And lastly, this is the shape where the continents are showing lastly with it, and this is the continents of the earth according to Alfred Wagner. The mantle of the earth. The mantle of the earth is divided into sections which are based upon results from seismology. The upper part of the mantle extends from 75 kilometers below the crust of the earth, below of the surface of the earth, and to 410 kilometer, which is composed of plastic flowing materials, rocky materials, dissolved rocks materials under high pressure and temperature. So the transition zone between these two parts of the mantle starts from 410 kilometers to 660 kilometers, and this transition zone, we call it the Repti limit, or Repti transition, or Repti discontinuity. These zones has been distinguished by sending seismic waves below the Earth's surface, and the seismic waves were produced from the nuclear explosions happens at the surface of the Earth in the 1960s of the last centuries. So and we also made some receiving stations separated, distributed at the many places at the Earth's surface. These stations received the information from the seismic waves traveling through the Earth continents and feed back again to the surface of the Earth. It has been received in the receiving stations, and been also analyzed and understood, and give us a huge information about the interior phases or spheres of the Earth. Usually the seismic waves can penetrate solid and the liquid materials, and some of the shear waves, for example, has some properties that indicates that it cannot penetrate the liquid or can penetrate the solid materials, and the P waves can do the opposite property to us. Therefore, we can measure these two types of the waves and understand which state these materials are inside the Earth planet, inside the planet Earth. The lower mantle extends from 660 kilometers to a depth of 2,891 kilometers, and there is also a transition zone or a boundary or a limit or a discontinuity in the seismic waves named as Gutenberg limit due to the person or the as to be referenced to the references to the person who discovered it. It is Gutenberg a scientist called Gutenberg. So the mantle of the Earth is a huge store for the chemical elements we know at the surface of the Earth. The mantle is made of 44.8 oxygen, 21.5 silicon, and 22.8 magnesium and iron. There are also another type of elements like iron, aluminium, calcium, sodium, and also potassium chemical element. The elements are bonded together in the form of silicate rocks in oxide form, which means that these elements, as aluminium, is bonded with the oxygen, calcium is bonded with the oxygen, sodium is bonded also with the oxygen as molecular. The most common silicon oxide is the SiO2 at 48% component composing the mantle of the Earth, and we have followed by the magnesium oxide and also the ferrous oxide, which is the iron oxide, and at the composing around 37.8% of the component in the mantle of the Earth. Example of rocks include minerals and are the olivine, the pyroxene, the spinel, and garnet. The core of the Earth extends from 5,100 to 6,370 kilometers and composed of iron nickel alloy under high pressure and temperature, and the pressure and the temperature measured at the core of the Earth is the equivalent to the temperature at the surface of the Earth, which has been measured around 5.6 million degree centigrade. Earth core is an important sphere because it contributes with the mantle of the Earth to generate Earth magnetic field. The Earth magnetic field is protecting the planet Earth from sun radiation and protecting also the life cover or in the biosphere of the upper spheres of the Earth. The place or the zone or the sphere, what we call it, the core, starts from here, from this area, and also spherical, showing here in this area, and this area to the center of the Earth is the core of the Earth. So there are also some discontinuity in the seismic waves. We call them the Gutenberg discontinuity or transition to the materials from a state to another state. From, for example, for the mantle of the Earth, it is materials in the lower part of the materials are suffering from higher pressure and temperature from the materials in the upper part of the mantle. Therefore, we have a discontinuity show ups in the seismic waves, which is received in the at the receiving station at the Earth surface, distributed at the Earth surface. We have also the mantle. The core of the Earth is also separated from each other due to the transition zone between them, and this transition zone we call it Lehman discontinuity zone. The outer core of the Earth is does not transmit the shear waves, and this gives us an interpretation that it is a liquid state. The outer core is in liquid state, just like the sphere above it, which is the lower mantle. Again, the temperature, the state of temperature and the pressure is higher than the materials in the lower mantle. The core of the Earth is also separated from the inner core by a transition zone. We call it the Lehman transition zone, according to the person who firstly distinguished such transition in the seismic waves. The inner core transmits the shear waves at very low velocity, suggesting that it is a solid or partially molten state. The spheres, the interior spheres of the Earth are three, as mentioned before. The core here is separated from the outer core of the Earth, and it is made of iron and nickel alloy in two different states: in the liquid state, the outer core, and also the solid state in the central of the Earth, which is also pure iron nickel alloy. So we have the mantle of the Earth is in a liquid state and suffering from a very high extreme temperature and pressure states. And the mantle of the Earth is a huge storage for the chemical elements we know at the surface of the Earth. These chemical elements come up to the crust of the Earth through the many millions of volcanic eruptions happen to the at the surface of the Earth, where materials from the mantle come up in two states: the liquid state, which has been crystallized to rocks and minerals, and the gas state, which has been added to make the upper spheres of the planet Earth. Earth. And lastly, we come to to offer some conclusions to the subjects of today. The Earth interior is composed of materials under high temperatures and pressure. So the crust is an active area for earthquakes and volcanic eruptions, which should be localized wherever an engineering project take place. The mantle is in a spherical shape and contains plastic, liquid, rocks, materials under extreme high temperature and pressure. It has convection currents, moves around the core of the Earth. The movement of the mantle materials around the core produce Earth magnetic field. The core of the Earth has four main tasks or reasons. The first one is responsible for the generation of Earth magnetic field in collaboration, of course, with the materials in the mantle, which suffering from the convection currents, moves from the high pressure and temperature to lower pressure and temperature near to the Earth crust. The core contains information regarding the earliest history of creation of our planet Earth. The core influenced in the evolution of the mantle, the sphere mantle, the crust of the Earth, and the upper spheres that covering our planet Earth, which is the atmosphere, the hydrosphere, the biosphere, and also the lithosphere. Because it composes of iron in a solid state, it plays a significant role in generation of Earth magnetic field. Well, my name is Sabah. I am an engineer geologist, and my next presentation will cover the subject geological time scale. I will try to present this subject in details, and therefore I will separate it to four presentations. The first one will cover the creation of our solar system, the other planets in our solar system, the creation of planet Earth, the creation of our moon, and also the creation of planet Earth, and the development happened at the surface of the Earth during the geological time scales, beginning with the Phanerozoics and the Precambrian and also the Cambrian ages, which can be resumed in the Paleozoic, the Mesozoic, and also the Cenozoic periods and ages. Lastly, I would like to thank you for watching this presentation, and please do not forget to give us a thumb up, like, share this video to your friends, subscribe, and also click on the bell below there. That will help us to and encourage us to go further in this type of presentations. Please do not forget to give us your your suggestions. Your suggestions are very important for us to make better presentation in the near future. Well, thank you again for watching this presentation, and take care.